Quantum numbers. There are a set of 4 quantum numbers. 4 quantum numbers. With the help of which we will get the complete information about the electrons in an atom. Okay, so each quantum number represents different size of the orbital. Okay, gives the size of the orbital, then shape of the orbital, then it gives an information about the orientation of the orbital and spin of the orbital. Okay, size of the orbital means if the size of the orbital is too small means the electrons are very close to the nucleus. Okay, then shape means each orbital is having particular shapes. Okay, within which the probability of finding the electron is maximum. Okay, next orientation. Orientation means the direction along which the electron is present, and fourth one is spin. Spin means the electrons are having either clockwise spin or an anti-clockwise spin. So that information also we will get from the quantum numbers. Okay, so we will get a complete information about the electron present in an atom by using these 4 quantum numbers. 4 quantum numbers are principal quantum number, then azimuthal quantum number, then magnetic quantum number and spin quantum number. Okay, now we will discuss one by one. First one is principal quantum number. Principal quantum number. Which is denoted by n. Okay. Principal quantum number represents the main energy level or shell. Main energy level or shell in which the electron is present. Okay. It is denoted by the letter small n and it determines the size and energy of the orbital. Size and energy of the orbital. Okay. As the n increases, the energy of the orbital increases. Energy of the orbital increases. Okay. Next point, it can have whole number values. Okay, it can have the whole number values 1, 2, 3, etc. So, first shell, second shell, third shell, etc. It is numbered like this. And the name designated to these shells are K, L, M, N, etc. Okay. So, these are named as, these energy levels or shells are represented as 1, 2, 3 and the name is K, L, M, N, etc. Okay. And next to the number of orbitals, allowed orbitals are given by n square. Allowed orbitals are n square. Okay. These are the important points of principal quantum number. Okay. Second one is azimuthal quantum number and it is denoted by the letter small letter L. Okay. It is also known as orbital angular momentum quantum number. And subsidiary quantum number. It's also called as or subsidiary quantum number. It defines the three-dimensional shape of the orbital. Three-dimensional shape of the orbital. Third point, it is noted by letter L. L determines the magnitude of the orbital angular momentum of an electron present in the shell. Okay. L. determines the magnitude of orbital angular momentum of an electron. Orbital angular momentum of an electron. Then it denotes the subshell. It denotes the subshell in the given principal energy level of an electron. Okay. In the given principal energy shell or energy level in which the electron is present. Okay. Okay. Now its value depends upon the principal quantum number n. Okay. So it can have the integral values ranging from 0 to n minus 1. That means L can have the value 0, 1, 2, etc. n minus 1. Okay. Now this depending upon this value value of L, the different subshells are designated as S, P, D, F, etc. Okay. If L is equal to 0 means the electron is in the S subshell. Then L is equal to 1 means P subshell, 2 means D subshell, etc. Okay. Next, each shell consists of one or more subshells. Okay. Each shell consists of one or more subshells. Just take some examples. N is equal to 1 means L is equal to 0. L is equal to 0 means electron is in the S subshell. Okay. Now, if N is equal to 2 means what? N is equal to 2 means L is equal to 0 and 1. So, electron is present in S and P subshell. Okay. These are some examples of determining the L value. Okay. Third one is magnetic quantum number. It is denoted by small m or ml. Okay, so it is denoted by ml and it refers to the different orientation of the electrons present in a subshell. It represents the orientation of electrons in the subshell. Next point, it determines the number of orbitals present in any subshell. It determines the number of orbitals present in any subshell. Okay. ML depends upon L value. Okay. ML depends upon Azimuthal quantum number, that is L value. And for a given value of L, there are 2L plus 1 permitted values. Okay. Permitted values for ML. Okay. So, this ranges from ML ranges from minus L through 0 to plus L. Okay, and it can have 2L plus 1 values. So, let us take one example. L is equal to 0 means ML is equal to 0. Now, if L is equal to 1, ML will be having minus L, 0 plus L. Okay, so this contains 2L plus 1 values, that is L is 1, so 3 values. Minus 1, 0 and plus 1. Now next example, if L is equal to 2, then ML will be equal to minus 2, minus 1, 0, then plus 1, plus 2. Okay, so 2L plus 1 values are 5 values. Like this, we can find the ML values and which depends upon the value of L. Okay. Fourth one is spin quantum number. It is denoted by S or MS. Okay. It describes the spin orientation of the electron. Spin orientation of the electron. Okay. This electron can have two ways of spin. Okay. In clockwise direction and in clockwise direction. Electron can spin only in two ways. Clockwise spin and anti-clockwise spin. And this spin can either have the value plus half and minus half. Okay. So the values of spin are plus half and minus half. Okay. Next, depending upon this plus half and minus half depending upon the direction of the spin. Okay. If it is in clockwise direction, plus, and anti-clockwise direction, minus. Okay. An orbital cannot have more than 2 electrons, and these 2 electrons are in the opposite spin. Okay. An orbital cannot have more than 2 electrons. And these electrons are in the opposite spin. Electrons are in the opposite spin. Okay, this spin quantum number was proposed by two scientists, George Uhlenberg and Samuel Goudsmit in 1925. Samuel Goudsmit in 1925. Okay. These are the important quantum numbers which helps to identify the electrons present in an atom. Okay. Now let us do one problem based on this. First one, an electron in an 4f orbital. What possible values for the quantum numbers n, l, m and s can have? Okay, so 4f orbital. So what will be n value? N will be is equal to 4. Okay, now next L value. What will be L value? L value, this is in the F subshell. That means L is equal to 3. Okay. Next, ML value. ML contains 2L plus 1 values. Okay. This will be equal to 12 plus 1 values means 7 values will be there. So, minus 3, minus 2, minus 1, 0, then plus 1, plus 2, plus 3, 7 values. Then what about S, MS or S value? MS value depends upon the values of M. For each M value, MS will be equal to plus half and minus half. So, each M contains plus half and minus half. Okay, like this. So, these are the values, the possible values for N, L, M and S. Okay.